We are being asked to graph the given functions f and g in the same rectangular coordinate system, and then we're going to describe how the graph of g is related to the graph of f. So I want to first start with the graph for f of x, and they tell me f of x is equal to 2x. Now, the easiest way to graph a linear function, especially when it's in this form, is to think of y equals mx plus b. And so the number in front of your x we call the slope, and we want to think of that as your rise over your run when you are graphing points. And then the b value we refer to as your y-intercept. And we think of that as your starting point on your y-axis. Now, you'll notice that this particular function does not have a b value. And so, technically, it means that the b value is 0. They don't write it as 2x plus 0, but we have to understand that's what it means. So, we would put our starting point on the graph at a y value of 0. My slope in this case is a positive 2. Now, because I want to think of that as rise over run, I'm going to write it as a fraction 2 over 1. And so the rise refers to a vertical movement. If you have a positive number, you go up. So in this case, positive 2 tells me I will move up 2. And then the run refers to moving left and right. And again, if you've got a positive number, you'll go right. If you have a negative number, you will go left. And so in this case, we're going to go right 1. So from my starting point on the graph, I will count up 2 units and over 1, and then put another point. Okay, and then I can keep doing it, up 2 units and over 1. Now, I'm going to make the points bigger than my counting. And so when you're counting, you have to do the up 2, right 1, and then put the actual point. So that's what that particular line would look like. Okay, so we'll do blue for the next one. So function g of x, if I look at that, is 2x minus 5. And again, if I think of my mx plus b, notice in this case, my y-intercept is at negative 5. So on my graph, I will put a starting point at negative 5. And my slope in this case, my m value is still positive 2. So I think rise over run. So once again, I will be going up 2, and I will be going to the right 1. So from that starting point, I'm going to count up 2, right 1, put a point. Up 2, right 1, put a point. And then connect them. So you'll notice that those lines are never going to cross each other. We would call them parallel lines. And the reason they never cross each other is because they have the same slope. The other thing that I noticed when we talk about how g is related to f is the fact that all of the points on function g, which is my blue line, are 5 units down from the points of function f, which is my red line. So we call that a vertical shift. So like, for example, if you look at the y-intercept here compared to here, the function g is 5 units down. And if you picked, another x value and you looked at, say, here and you compared it to there, it's 5 units down. So they're parallel lines, and then what we say is g is shifted down by 5 units. Now, one other thing I want to point out here, if you ever get, let's say, a negative slope, let's say we have the equation y equals negative 3x plus 1, and so in this case my slope is negative 3, still put it over 1, and what you need to realize is that negative is either on top or bottom, but not both. I typically just put it on top. So in this case, since it's a -3, you would actually move down 3. And then don't put the negative on bottom as well. It's one or the other. So it's on top, that's down 3, which means your run would be +1. And when it's positive, you would go right. So just be careful with the negative because it does not apply to both top and bottom.